Question 13 is an algebraic proof question. We've not done these yet in class, but I'll show you how to do them anyway. And the trick is to write down some algebra for consecutive even numbers. Okay, now if you think about an even number like 2 or 4 or 6 or 8, it's like a little sequence. And the rule for this sequence would be 2n. So that's what we usually do to represent an even number. So my first even number is going to be 2n. If I need two consecutive even numbers, my second even number will be 2 more than my last one. So my other even number, I'm going to use 2n add 2. They will be always two consecutive even numbers. So not just 2 and 4 or 4 and 6. Anything. 200 and 202, a million and a million and 2, they're two even numbers, no matter which two numbers we choose. So it says, prove that the difference between the squares of these two numbers. So we have to square these numbers now and find their difference. So the difference is when we take them away. And notice I started with the bigger number. I started with the 2n plus 2. It says prove that that is always this twice, so 2 lots of the sum of the numbers. So 2 lots of 2n plus 2n plus 2. Okay, now in order to do this, what we have to do, there's some specific rules with proof. We're not allowed to touch this right hand side. Similar to that surds question that we've just done, we have to turn this into this. We can't change this to make it look nicer, we have to leave it as it is. Anyway, let's start by expanding these brackets. So I've got squares, so I need to write it out twice. This one's okay, this is just 4n squared. But I'm going to multiply these out, so that's going to give me 4n squared plus 4n plus another 4n plus 4. I've still got my minus 4n squared. The 4n squares actually cancel out, you can see. So that leaves us with 8n plus 4. And now we've got to start being clever. We've got to look at what we're aiming to get to. So you can see I've factorised out a 2. So let's take the 2 out. So that will give me 4n plus 2 left. And I can then split that 4n into 2 2n's. So that's it, we're done. So as required. These algebraic proof questions are really difficult. We will do them in class, we will practice them a lot, but you kind of just have to know the steps to take. They're not very interesting, they're quite boring, but they are, in the old papers, they are A-star questions.